basically energy. Your best definition, if you're looking for like what's the Mr. B approved awesomest best definition, it's a disturbance in a medium that transmits energy. That's the magic definition. But the key thing is, what are they doing? They're doing transmission of energy. That's what they are. That's what makes them different than simple harmonic motion. That's what makes them different than pendulums or springs. They transmit energy. That's what makes them different. All right. Good. So, what happens to the wavelength as you increase the frequency? So if you make it happen more often, then they get closer together. So if you increase your frequency, you make them happen more often. They get closer together. So your frequency will make your wavelength decrease. Okay? Jensen, what about 4? What happens to the period as you increase its frequency? So if it happens more often, what's going to happen to how long it takes to make that wave? Yeah, because how long it takes you to make the wave. So if you get, so for example, if you have 10 waves per second, and now you increase that to 20 waves per second, what's going to happen to how long it takes to make each of those waves? It's going to take less time. Each wave is going to take less time to make. So that'll decrease your period. Okay, let's talk about numbers 5 and 6. So this is these are two that a lot of people have questions about. These are two that a lot of people have questions about. Drawing and doing, explaining constructive and destructive interference. So we did this in the Slinky lab. These weren't on the notes. This was in the Slinky lab that we did. So constructive and destructive interference, how do you go about doing that? So constructive interference is when they add together to make a larger wave, and destructive interference is where they cancel out to make a smaller wave. So there's two ways that you can draw it, and I'll show you both ways here. So here's the first two ways that I would go about doing it. You can either do what we did in the Slinky lab, which is we drew two waves going towards each other, and then we showed what happened when they met in the middle. So for constructive interference, you have two waves that are identical. They meet in the middle, and they add together to make this kind of like super monster wave. The other way you could draw it is you could draw two identical waves. So here I have two waves identical to each other. And if they overlap with each other, they're going to make the same wave, but much larger. And that's constructive interference. So constructive interference is when you have two waves that overlap that make a larger wave than you would normally. So that's constructive. Destructive is the exact opposite. So it's two waves, they add together, but they're two opposite waves that add together. So two waves on opposite side of the medium, one up, one down. This time they subtract from each other because one is positive and one is negative. So they cancel each other out. Or you could draw it like this. One wave that starts down and ends up, another wave that starts up and ends down. If you add those two together, they're going to cancel out because one wave is going like this, while the other wave is going like this. So they're canceling out with each other. Okay, any questions on interference? That's two of the more confusing ones, and we just talked about it in the lab. We haven't talked about it outside the lab, so it's easy to miss that or been confused on that. So any questions on interference stuff? Okay, let's jump to the back page. Let's look at another one here. Let's look at number 15. Nope, not 15. Which one do I want to look at? Oh, 14. What are standing waves and why do they form? So standing waves we also did in that lab. And those were the waves where we just made the slinky go back and forth, and you just flip-flop, 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 flip-flop. It didn't look like it was going down the slinky. It looked like it was just alternating back and forth, back and forth, back and forth. That was a standing wave. So a standing wave is alternating waves of crests and troughs. So it's a wave that's a crest, then a trough, then a crest, then a trough, then a crest, then a trough. But it doesn't look like it travels. It looks like it stands still on the medium. It just flip-flops. Okay? And here's the big question. Why do they form? And they form because of interference. So what they're doing is they're doing one round of constructive interference and then a round of destructive interference. Then a round of constructive interference on the opposite side, then a round of destructive. Then a round of constructive on the first side, then destructive, and so on and so forth. So it's constructive, destructive, constructive, destructive, constructive, destructive, constructive, and it's just continuously doing that. So one set of waves goes this way, one set of waves goes this way, and they just keep overlapping with each other. Okay? And they overlap as the same, then opposite, then the same, then opposite, then the same, then opposite, and they just keep doing that. Okay. All right. Let's jump back and let's take a look at. So amplitude is the size of the wave. So the large wave would be larger amplitude, so the actual size of the wave gets bigger. And smaller amplitude would be smaller in size. Notice I didn't change the frequency on this one. I left the frequency the same. I'm mostly looking for the size of the wave, but you want to be careful about the frequency too. And then again on the frequency, so more often doesn't have to have a different amplitude. Less often is a smaller frequency. Larger amplitude, smaller amplitude, again, doesn't have to change the frequency, just like this doesn't have to change the amplitude. So there's that to look at. All right. Next ones I want you to look at, I want you to jump down to 16 and 17. Jump down to 16 and 17, the two problems. You're going to see some problems on the test. The test is all going to be multiple choice, including the problems. But there are a couple of math things that you should be able to solve. So try your hand at 16 and 17. See what you can come up with on those two. And frequency would be waves over time, so that would be 9 over 15. So period is the time it takes to make one wave. Frequency is the number of waves that happen in one time. In this case, in 1 second. Okay? And then for the last one, so the equation we're using is the V equals F lambda. So the V is given, it's 3 meters per second. Where you have to be careful is it seems like the frequency is 10, but it's not. It's 10 seconds for the next wave crest to reach you after the first one passes. So after the first one passes you, it takes 10 seconds for the next to get to you. So to find the frequency, you got to take the number of waves that are made. There's one wave that passes you, and it takes 10 seconds. So you make 0.1 wave per second, or have a frequency of 0.1 hertz. So that would be your frequency, 0.1. You would divide that to the other side, and you get 3 over 0.1 to get 30. All right, I want to talk about 15, and then I'll give you the rest of the period to just finish up. I am going to check the study guide next time. So we've gotten most of it done. We've only got like 5 that we haven't done, so you can finish those up the last part of the period, and then you'll be all finished. 15, what affects the velocity of a wave? So I know the equation is frequency times wavelength, and so you would probably assume it would be the frequency and the wavelength. But that's not what affects how fast it goes. See, when I talk, or if I sing, heaven forbid, but here it comes. I'm a top-level singer. I know. So if I change my voice, I'm changing the frequency. But I didn't change how fast it went. So it can't depend on the frequency. That also changed the wavelength, so that also can't affect the velocity. So the thing that affects the velocity is the medium. What it goes through is what affects it. Okay? If I sing in the water, it's going to have a different speed than if I sing through the air. And if I sing through the ground, I like shout into the ground or something, apparently. Going to send messages to China. Then that's also going to travel a different speed. So if you send a wave through a medium, different medium, it's going to change the speed of that wave. So the speed of the wave depends on the medium it goes through. It does not depend on the frequency and the wavelength. Instead, the frequency and the wavelength depend on the speed. Okay? So depending on how fast the wave is, that'll change the frequency and the wavelength. For example, a 300 hertz sound that you can hear through air will have a different wavelength through the water. So through the water, it'll have a different wavelength because it goes faster. So that'll change. It'll be the same frequency, but it'll change the wavelength. So the velocity depends on the medium. So all you should have left to finish, and I'll give you the last bit of the period to do that here, is 10, 11, 12, 13, and 2. So use your time to finish that and get it done. You'll be all done with the assignment for next class. You'll be able to get that checked off right at the start of the period. And then we'll be able to do the test and you'll be in good shape. If you have any questions, let me know. But try to finish that up here real quick.